Hi, this is the demonstration for EE104 lab for the hardware part, that is to design the uh, the signal night. Well, go to the results for my project. Is I didn't finish the whole thing, but I tried myself to achieve as much as I can. So let's start with the state machine design. It's exactly same as what the professor listed in the lecture. And I create the K-map right here to find the relationship for the Q2 and Q1 and the next states, the relationship for the next states and the input or the relationship between the input button and the counter. And here's the output design. I used actually a 3 to 8D coder to generate the output to the signal lines. Well, the output is basically process a 3 to 8 decoder. So for the output C, I just assume that's 0 and the output B is equal to Q2 and the A is equal to Q1. And here is the floor figure according to the results ahead. And here is the testing form for my work about the testing part, because the circuit cannot achieve the signal night transfer. Well, I'm gonna show you a few video now. Here is the video for 7 segments, and as we can see, the light right here is on when the counter continue 9, and this node is the input for the counter input, right? Once the counter line and the counter input is on, and the next picture is showing that here is the signal line system. Well, because the output from the 3 to 8 decoder is only can achieve like 3.3 volts, so the power cannot light on all the LEDs. But as we can see, here is the assume the light on the Santa Clara, and here is the light on the 7th Street, and right. This video shows the states change according to the from the different flop, but obviously it's wrong because it's wrong because of something inside the circuit, but it displays the state machine change. And next picture is to display the, well, here is the way I'm going to test it separately. I don't know why once I only tested the output, the signal lines, the power is enough, but when I connect everything together, the power is not high enough. And here is the output of the S0, Santa Clara green and South Street right. And here, I just changed the input of the decoder. So I can see here's the output of S1, Santa Clara yellow, and the 7 still is right. For the next day should be red and green. That's next day red and green. go to the final state, red and yellow. So the output display should be correct if the whole circuit working. Okay. Now let's go to the testing form right here. I just simplify the circuit in this way, and the B input and the Q2 had through the AND gate is node X, and here's the node Y. Over here, here's node Y, and here's node Z, and I just test the node output in my circuit to try to see what's the output, logic output correct or not. When I test the voltage output is about 3 volts or high means logic 1, logic on. And once I test the voltage about only like 0.1, 0.2 volts, that means the logic low. And here is the testing form for each situation when the S0 state, what's the output supposed to be, and S1, S3, S2, and go ahead. Well, that's how I test. Okay, let's see what I didn't figure out in the project. Well, one of the bigger problem is the clock. The 555, I don't know why the 555 generates the waveform. It's not stable once I connect everything together. Sometimes it cannot trigger the flip-flop. That means when I test when the D input over here is high, but the Q2 is still no, because the 555 doesn't work. And sometimes also the voltage across the components is not high enough. Sometimes it's not. It's the problem I cannot figure out. Even I change some chips, change some components. This problem I have mentioned before, and another thing is about the bottom input. I try to connect to the bottom one side with the VCC and another side with a resistor, and to the very high resistance resistor, and connect it to the ground. But I don't know why even I didn't turn on the button, didn't push the button, the output with the no logic no is still having 1.6 volt. That makes the inputs always high in the real circuit. That's a problem I didn't figure out. So by the end, I just tried to connect the bottom input manually with my hand from the VCC to ground to try to test it. Let's see what I did. Thank you for listening.